in 1 and 3 states. Solid, liquid, or gas. Everything there is comes in 1 and 3 states. Solid, liquid, or gas. Solid materials won't change shape unless our force is applied to them. Solids always take up the same amount of space. You can hold solids in your hands. So example, trees are solid, bees are solid, bricks are solid, chicks are solid, rocks are solid, socks are solid. Everything there is comes in 1 and 3 states. Solid, liquid, or gas. Everything there is comes in 1 and 3 states. Solid, liquid, or gas. Liquids can flow and be hard to hold. They fit the shape to the container. The volume of a liquid always stays the same, no matter what shape it is. So example, water is liquid, soup is liquid, rain is liquid, milk is liquid, seas are liquid, oceans are liquid. Everything there is comes in 1 and 3 states. Solid, liquid, or gas. Everything there is comes in 1 and 3 states. Solid, liquid, or gas. Gases are mostly invisible. They don't stay fixed in a shape. They can change their volume to fill up a space. Be squashed and blown around. Some examples: steam is gas, air is gas, oxygen is gas, helium is gas, and don't forget there's natural gas. Everything there is comes in 1 and 3 states. Solid, liquid, or gas. Everything there is comes in 1 and 3 states. Solid, liquid, or gas. Everything there is comes in 1 and 3 states. Solid, liquid, or gas. Everything there is comes in 1 and 3 states. Solid, liquid, or gas.
Hey everyone, how are we going today? My name's Hannah Troy, and in today's experiment we'll be investigating whether hot or cold water will freeze. Now, most of us is going to say that cold water will freeze first, right? However, in the 1960s, Erasto Mapomba from Tanzania claims in science class that ice cream would freeze faster if it was heated before being put in the freezer. This was due to evaporation, so if the water is initially hot, cooled water at the bottom is more dense than hot water at the top. This means no convection will occur at the bottom and it will start freezing while the top is still warm. Our experiment today relates to changes of state. Changes of state are physical changes in matter. They are reversible changes. Common changes of state can include melting, freezing, condensation, and evaporation. So the aim of our experiment today is to investigate whether hot or cold water will freeze first. Now let's find out. In this experiment, you will need 2 cups of water, 1 hot water and 1 cold water, a stirrer, a freezer, and a stopwatch. So, first step, we are going to get our hot water and cold water into our 2 cups. We're going to give both of them a stir, and then we're going to pop them in the freezer and check them every 10 minutes for any changes. The hot water has got a thick layer of ice on the top and the cold water is still a bit icy. In the first check, the hot water became cool but no sign of being frozen. The cold water became a bit icy, but neither of the cups were frozen. In the second check, the hot water began to show a thin layer of ice on top. The cold water was still icy, but still neither of the cups were frozen. In the third check, the hot water cup began to freeze quickly. The cold water cup also began to freeze from the bottom to the top, but neither of the cups were fully frozen. On the fourth check, the hot water cup was fully frozen, with the cold water cup being frozen, but still watery throughout the middle. Results were expected as we found hot water is less dense on top and it froze on top first. The limitations of this experiment could include the temperature of your freezer at home and also how hot your water is or how cold your water is. This experiment is also quite time consuming, hence why 20-minute checks were used instead of 10-minute checks.